Today we're learning about 4.4, explaining the trends of atomic radius. That's how big atoms are, the ionization energy, the energy it takes to remove an electron, and electronegativity, which is attraction for electrons when forming a compound. So first, look at a periodic table. Think, what do you think the smallest atom is on the whole periodic table? So you probably think it's either hydrogen or helium, because they have the smallest masses, the smallest atomic numbers, smallest number of protons, least number of electrons. So, hydrogen or helium. Let me draw them for you. A hydrogen atom has one proton and one electron. A helium atom has two protons and two electrons, and it's a little bit smaller because it has more protons, 2 protons versus 1, and the protons are positive, and so they attract the electrons more. The electrons get pulled in farther, and the outermost electron determines how big an atom is, so then helium atom is smallest. Helium atom is smallest on the whole periodic table. You need to remember that. I say rememberize because it should make sense, but you have to study a little bit to make it stick. What do you think the biggest atom is on the whole periodic table? It's francium. So if you are looking at a periodic table and I said which is biggest, you would think it was one of the ones at the bottom, but you might want to pick something more on the bottom right, but it's not that one. It's francium on the bottom left because it has 7 layers of electrons. Each time you go down in a period, like hydrogen to lithium, going down the periodic table to sodium. As you go down the periodic table, you gain another layer of electrons. So hydrogen has 1 layer, lithium has 2 layers, sodium has 3 layers. If you get all the way down to francium, it has 7 layers. So that makes it big. And for all the atoms that have 7 layers in francium's period 7, then francium has the least protons. So electrons can stay out the farthest. Okay, the trends of ionization energy, how hard it is to remove an electron. Well, if you have a smaller atom, its electrons are closer to the nucleus and more attracted, so it's harder to remove one. So this is the opposite trend as size. It's an inverse relationship to size. So, smaller atom, higher ionization energy. Bigger atom, lower ionization energy. So think to yourself, which element on the whole periodic table would have the highest ionization energy because it's the smallest atom? So I told you to remember the smallest atom was helium. So helium would have the highest ionization energy. Because its electrons are closest to the nucleus, it would take the most energy to remove one. So remember that helium has the highest ionization energy because it's the smallest atom. And so then the lowest ionization energy would be, think about it, what would be the lowest ionization energy? It would be the biggest atom, which you need to remember is francium. So francium is the lowest ionization energy. Last trend that you need to study is electronegativity. So let's summarize the first two and then we'll do electronegativity. So on an outline of the periodic table, you have the biggest atom, francium, down here. You have the smallest up here. So helium, smallest, francium, biggest, and our trend for smallest to biggest is as you go down, atoms get bigger because you're adding energy levels. As you go to the left, atoms get bigger because there's less protons to draw the electrons in. So the trend is towards the lower left, smallest to biggest. That's atomic radius. The other trend is the opposite, ionization energy. Ionization energy. The francium has the smallest ionization energy because it's the biggest atom. Helium is the largest ionization energy because it's the smallest atom. So those are opposite trends, inverse trends. Okay, lastly, we have electronegativity. Electronegativity trend points the same direction as ionization energy, but there's one change. Electronegativity is defined to be attraction for electrons when forming a compound. There's 3 elements on the periodic table that have never been measured to form a compound. Those are the first 3 noble gases. So because they don't form a compound, and because that's part of the definition for electronegativity, helium, neon, and argon do not have an electronegativity. It's not the smallest, they just don't have one. So it's definitely not the biggest either. So because of that, electronegativity stops its trend right here at fluorine. So fluorine has the highest electronegativity on the whole periodic table. So study those trends and be able to answer questions about which has a bigger radius, or which has a higher electronegativity, or which has a higher ionization energy, or which is a smaller radius, or rank elements in order, like put scandium and manganese and aluminum in order of increasing atomic radius or something like that. These trends are pretty important for forming compounds, for reactivity, like which element is most reactive, and when you're making alloys of metals or trying to make glass stronger, the size of atoms is pretty important for fitting the atoms together.